Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
And this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we have a studio full of stuff tonight, so some really interesting stuff. Just start off in recognition of the deep history and culture of this island, Tasmania. We would like to acknowledge and pay our respects to the all Tasmanian Aboriginal people, the traditional owners of the land upon which we meet. So now we've got a few things to show and tell tonight. Just first off, though, if you're watching via the streaming channel, please let us know you're watching and where you're coming in from. We're also listening on repeater 2, so you can call in there if you've got any questions or any queries. So tonight, I want to start off the WIA has a consultation, an exposure draft of the consultation paper out for exactly that, an exposure of the WIA position. It's out there along with a survey, so that we can gather some feelings from the amateur community around the latest of the ACMA's consultation papers around moving to a class license. So I encourage people, if you're a WIA member, you would have automatically got an email a couple of days ago which had a link to the survey, and you can just go to that, fill it in, all of that sort of thing. So I encourage people to do that so that we get your views about the consultation, about moving to a class license. There's a whole lot of questions around high power. There's some questions around call signs and the call sign register, and a whole lot of other bits and pieces to do with the ACMA consultation. So I encourage people to actually go in, have a look at the exposure draft, do the survey, and let us know, let the WIA know. The Spectrum Strategy Committee, of which I'm part of, has been doing a huge amount of work on this, and so we really want to hear now from the community. The survey closes, I think, early next week. We've then got a couple of days where we put the survey responses together into the response to the ACMA, and then we submit that on behalf of the amateur community. So please, if you haven't, have a look at it, have a look at the survey and let us know what you think. Now, the other thing that's happening in that space is this Friday, 8 p.m, there is a live session with a couple of the board members, Scott and Lee, and also Grant, VK5GR, who is on the Spectrum Strategy Committee as well, which is a bit of a Q&A session, bit of an information session about the WIA position and the survey, etc. So that's going out on the Ham Radio DX channel, VK7HH's channel, so worth a bit of a look. 8 p.m. This Friday night. Hello to Anthony, VK7AG from Blackmans Bay. Welcome on board. Now, one of the talks at the Tassie Ham Radio Conference back on the 5th of November was given by Peter Cousins, VK3 BFG. And he gave us a talk on digital amateur television and amateur television in Australia. A bit of a summary presentation on what was going on in the various states. One of the things he made reference to was the British Amateur Television Club, BATC. They have a project called the Portsdown 4 project, which is a DATV transceiver project using a Raspberry Pi. Now, when he mentioned that, after the conference had finished, I had a bit of a look on the BATC site at this Portsdown 4 project and realised that it was a very similar group to the Langstone project group. And in fact, the Portsdown 4 project group had incorporated in the Langstone project into the Portsdown 4 project. And I suddenly realised that I had all of the bits, because I showed a couple of months ago the Langstone Microwave SDR project on this channel, and suddenly realised that it uses exactly the same components as the Langstone project. So let me just, I'll zoom down the camera and we'll have a look, because sitting here in front of me, one I prepared earlier, is the Langstone 4 project. And let me see if I can get that's a bit better. So what you're seeing here is just below this, that is the Adelam Pluto SDR that we talked about as part of the Langstone. Now this has been, this has had the little hack done on it that takes it to 6 gigahertz. So this is a 6 gigahertz SDR full duplex transceiver. There's actually 2 transceivers in there, and there's 2 processors in there, that little box as well. Also, I've put the extra connectors on there to give it an external clock and a few other things. And then what's above that is a Raspberry Pi 7-inch touch screen, and sitting behind that is a Raspberry Pi 4 little microcomputer board, and that's been programmed up with the Portsdown 4 software. Now, what I will do is go to our close-up cam, because the close-up cam, the architecture of the Portsdown 4 project is, the heart of it is the Raspberry Pi 4. There are a whole lot of inputs that you can put in here, the various Pi cams, the various other cameras that you can plug in. I've got a USB dongle on here which I can take the USB audio in and out. There is also the ability to use an EasyCap capture USB capture card, which can capture video and audio, and that goes into one of the USB ports on the Raspberry Pi 4. There is a 7-inch touchscreen. Now, there is for the receiving side, there is a couple of projects that they have here, which is the Mini Tuner. This is a French project, ATV project, which is a little tuner. It's got a little Arduino on it. Enables you to receive DVB-S, DVB-T, over a whole bucket load of frequencies, from VHF up to microwave type frequencies. So this is one of the receiver options. There's a couple of other receiver options that are available to us here. Comes into the Raspberry Pi via USB. Now from the transmitter side, so this is the transmitter side, there's a couple of options here. There's a Lime SDR, there's a DATV Express, which is another ATV project, and there is a Pluto, which is the one that we're using. And these are all the transmitter options that give you transmitter outputs on a whole range of DVB-S, so the satellite standard, and also DVB-T, which is the terrestrial standard. And so this gives you the ability to configure, and you can see there's a whole lot of configurations that you can do on the touch screen on the front panel. Not only the frequency, but also symbol rates and forward error correction and all sorts of stuff on there. So it gives you the Raspberry Pi gives you the control surface, and the touchscreen gives you the control surface for both the transmitting side and also the receiving side. So it's pretty flexible and agile little system that's available to us, and relatively easy to actually to install. Let me just go. Ron RM from Sandy Bay here on RF. Here and on RF. Well, he's watching it in stereo with a scary amount of delay, I suspect, between the streaming and the RF. And Anthony, I read the WIA's draft response document today. Thought it was very well considered. Excellent. Thank you for the feedback. That's good. There's an awful lot of work gone into that particular document by a couple of people. So and the Spectrum Strategy Group. So that yeah. Now let's just some of the. I'll just read out some of the Pluto transmission parameters. So it's capable of H.264 standard only. So there's no MPEG-2 or H.265. It's either 4.3, so the old format, 16 by 9 or 720p. There's no 1080p available. Doesn't have enough processing power. You can set and store for each band. So the Pluto relative power output. This approximates 0 to 71. Approximates the dBm, plus or minus 10 dBm. The maximum frequency that you can transmit on is 4.1 gigahertz, so there's no 6 centimeter band. The comment he makes here, I've seen it work well past symbol rates of between 125 and 1,000 kilosample. So yeah, you need to stay within those parameters. DVB-S or DVB-S2, so the original standard or the updated standard. DVB-T from 150 kilohertz up to 1 megahertz bandwidth, so it's relatively narrow band. There are video sources from a PiCam via USB, composite video, the old style C920, and also a variety of test card. There's a test pattern generator that's built into the system, and a range. So there is some limitations. That's the Pluto limitations. There are also similar limitations for the Lime SDR and also the Express DVB-T. And hello to David VK7 AAE from Blackman's Bay down in Anthony's area. So. Some of the limitations that the Pluto specifically puts on it In DVB-S mode, a bug prevents transmission at forward error corrections of 5/6 or 7/8. All other forward error correction ratios are okay. And they just make a comment here, there's no plan to fix this. In DVB-S and DVB-S2 modes, if a call sign with a slash is used, so in this case G8GQDGKQ/P, the Pluto will transmit service 01 as a provider ID. Interesting if you put the slash in. The maximum supported symbol rates with the Pluto are 1 megasamples. If you want higher symbol rates, it's recommended that you use the Lime SDR Mini with the Lime DVB firmware installed. In most of these boards, and including the Pluto, there is a specific DVB firmware that you download to the Pluto to get it to work, and an audio source, either a webcam microphone or a USB dongle, which I've got plugged into that one, must be present and selected for DVB-S and DVB-S2 transmissions. And transmitting only a carrier is not supported by the Pluto firmware, so I can't demonstrate just putting out a particular carrier. Now the receivers, you only use the Pluto for transmission. You need a separate receiver. The Portsdown 2020 and the Portsdown 4, if you plug in the mini tuner, which is the French USB receiver hardware, into the Raspberry Pi's USB port and select receiver at the top menu, you will have access to a fully functioning DATV receiver. Now, I can't demonstrate that because I don't have one of those receivers. I'm working on that. The received signal is displayed on the 7-inch touchscreen. So if you go to the received signal, it creates a complete full picture on the 7-inch touchscreen. That's about the receivers. Now let's just do a bit of, just to prove that it is actually a working model here. I'll just squeeze through the Moxon antenna that's in here. So there's a range of things that you can configure here. There's a whole range of different areas that you can change. There's power levels. There is attenuation. Different types of attenuation. There is audio, how you want to pick up the audio. There's USB, there's the easy cap if you've got the capture card, etc, etc. There's a whole lot of little presets down here. There's 437 megs on the Lime and on the Express, etc, etc. I've got it set up for 445.5, which is the frequency that we're going out on for the RF version of this particular. So you can put it into preset 4 mode, which is set up the Pluto for 445.5 megahertz output. You can then go into transmit if you want to. Again, push the transmit button. There we go. The transmitter's on. Now it's quite low power, so I'm not. I'm probably. It would be overwhelmed by the 15 watts that our transmitter's being putting on. The receiver. If I push the receiver, it'll tell me that I don't have any tuners. The Nucker, which Peter talked about, or the mini tuner, aren't connected. It knows they're not connected. So there is a range of M1. Now I'll go into this in a short while. The Langstone. I'll show you the Langstone receiver in a moment. But there's a whole lot of things like signal generators. You've got band views. You've got the ability to use an RTL SDR, either as a client-server arrangement or just a receiver. The video monitor, if you're receiving, it gives you the received signal. The PiCam monitor, if you've got a PiCam plugged in, you can then look at the picture that's coming through on the input. HDMI monitor, you've got locator bearings, so you can put in your maiden heads and all of that sort of stuff. Sights, beacons and bearings, if there are ATV beacons and bearings around the place. Test equipment, this is one I want to show you. There's a whole lot of different test equipment that is built into the Portsdown 4 project. And there's a signal generator, band view, there's a power meter, so you can actually see how much power you're actually putting out via the Pluto. There's a noise figure meter, an XY display, so you can get like a constellation diagram of what's being put out on the Pluto. You can sweep over a particular frequency. There's an RTL SDR band viewer if you've got an RTL SDR plugged in. And there's a whole lot of configuration buttons that are available here. M3. M3 gives you all of your presets and how you configure bits and pieces. There is set the band details, set the frequency, set the locator and the PIDs for the channel. There is amend different bits and pieces, the audio out, line configuration, Langstone configuration, Pluto configuration, select test cards. There's a whole lot of test cards you can select so you can have a test pattern come up automatically. Check for updates, system configuration, all of the bits and pieces, so you can get to most things without having to go into too much. And yeah, it's quite an easy interface to actually use. One of the things that what I was going to show you, test equipment. No, we've already looked at that. Oh, no, I know what I was going to do. What I was going to do was actually show you... No, it must be M2. Yeah. Switch to Langstone. Now, one of the things that the Portsdown people have actually done is enabled you to incorporate in the Langstone receiver. So let's switch to... now, this particular line across here, for some reason, I think the cable on the back of this particular touch screen has come adrift. So these buttons here don't actually work. Everything else works, but that doesn't. So what I can do, there's another way of getting to the Langstone here. Langstone configuration. Here we go. So start Langstone. So what it does is goes in, downloads the Langstone firmware into the Pluto, and then it reboots the Pluto into a Langstone mode. So we just wait for that to happen, and it magically, here we go, the Langstone transceiver Pluto version is loading, and it will then come up with the frequency display that I showed. Here we go. So if we go to, that's 10 gigs, if we go to 1296.15 is the frequency that we use on the 23 centimetre net. In fact, what I'll do, I'll come back down a little bit here. All the stuff is, you've got your bands, you've got your modes that you select, you've got the ability to set up duplex and not duplex, and then you can set up the split. You can set up there are beacons and CW and dots IDs. There's your push to talk, so we're transmitting on 1296.15 at this point in time, using the Pluto, and you can also receive. I meant to bring my 1296 handheld with me, but it's sitting in the shack on the charger, so I can't demonstrate this, but I can guarantee if we were to transmit a 12. I know what we can do. Let's go to 144, and we can put in 146. and 700, and let's go to FM. Now 146.700 is the frequency of the repeater, and there we go. That's the repeater frequency on the Langstone being received. So so yeah, if somebody wants to come up on the repeater, they can see themselves on the Langstone receiver. So this is a full receiver up to 6 gigs, and with some up-converting mixing, you can go past 6 gigs up to, in fact, if we go to more, you can see 3.4, 5.7 gig, 10 gig, 24 gig, 47 gig, etc., and mix up way past that if you really want to. So that's the Langstone transceiver, which is built into the Portsdown software. So let's exit to Portsdown, and it exits out of the Langstone. Here we go. Pluto may be rebooting, which it may be. I don't think it is, because you can see the little heartbeat here. The little heartbeat LED is pulsing, which is always a good sign, because it means that the Pluto's up and going. There we go, and we're back into the Portsdown for transmitter in this case. We haven't got a receiver connected, but it enables us to take a video, take an audio feed, and transmit it in DVB-S, DVB-T, DVB-S, DVB-T, DVB-S2, and a whole range of other digital ATV modes, and it gets you up and going with digital ATV really quickly. So anyway, that's the. Oh, sorry. Go again on the on R2. Anyway, so that's the Portsdown 4 Langstone project that Peter Cousins VK3BFG, and I am sure that I'll be doing some more demonstrations using the Portsdown 4 and actually show you it transmitting on 445.5. We'll actually switch off our transmitter here and then go out using the Portsdown transceiver and see how we go. So very impressive little project out of the British Amateur Television Club's group. So absolutely fantastic. So now what I will do is I'll go to the and Ken VK7DY. Hello Ken, and we'll just do a bit of a reset of the studio, and we'll go to I'll go and grab Murray, because Murray's got a very interesting 6-meter Moxon project that's sitting here in the studio. So if Murray's out there watching, please come into the studio, and we'll just do a quick reset of the studio, and then we'll be right back. Just stand by. Here he is. I don't even need to do a reset of the studio. I love it. Just make your way into the studio.
The unceremonious entry.
And good evening to Murray, VK7ZMS, who's now in the studio, and I'm just getting you on the other camera so that we can zoom. Oh no, go the other way, go the other way, go down, go down, go down. There we go. That's cool. Now, Murray's in the studio because Murray came in with a very interesting 6-meter Moxon antenna.
I don't think the actual antenna is that interesting. It's a very ordinary 6-meter Moxon. It is off a field day van, and it does feature in on Hayden's YouTube channel.
Oh, definitely.
Ham Radio DX. He put did a video of us making this antenna.
Cool.
But on the day, we had not considered what we were going to do about the balun, and so we just air wound one out of coax and used that to test the antenna.
Which worked?
Yeah,
Very well.
No, it worked fine. But obviously there was nothing to support the antenna, and nothing to support the
Balun.
the balun.
Okay.
It was just hanging in midair and broke, I think, as we actually lowered it down. So
Right.
it was kind of inevitable.
Okay. But now
we have this lovely 3D printed balun holder.
we do.
I don't know if there's a name for what you
Balun.
balun call.
Balun.
Former. That's the word. That's the word. So this is one that was kindly 3D printed by Ken VK7 KRJ.
Who was at the expo?
He was at the expo.
He
He
had
had a lot of gear for sale at the expo.
Definitely.
And he came round for a coffee on the weekend, and I drew a very simple thing up that I wanted him to try and 3D print, and he turned it into a very complicated thing, and has done an excellent job of printing it. Here's, I don't know which camera we're on.
Well, we actually.
Oh, you want to put it over there?
We'll go over here. We'll go over here, and then we can do.
Oh, you can't really. There's a couple here. You can put that one on. There's a blank one there without the.
There's a. There we go. So
That's
very impressive. Very impressive design.
And yeah, so in the middle of it has that little tube that sticks out, so that the cable runs through. Probably better on this one over here if you move to this. Yeah, so this is the bottom of the antenna. This is the bottom of the boom when it's sitting up. That sits down, and so this former just sits here straight onto the driven element. There's a nice little guide down here to start the coil. Coils around. There's a little guide up here to hold it popping off the top. Goes through this hole here, straight through the middle, and there's a little strain relief post in there, complete with a little groove for the coax to go in, another groove for the cable side to grip to give you some strain relief, and then when it sits on the van, that just hangs straight down
And goes down the pole.
and goes down the pole. That's it. So looking forward to using that in the field day, which is not this weekend but next.
It is. I love it.
So looking to we're hoping for some openings on 6 metres. Oh, that's a better picture. Yeah.
Look at that.
So we'll be on Mount Wellington beaming north, hoping for some
Tropo action.
look, some tropo or some sporadic gear or whatever comes around.
I love it.
We'll find a frequency, and we're going to try about 50% transmit duty cycle on this for the first 8 hours of the competition.
Cool.
Just because when these openings happen, they don't necessarily happen for very long. So
correct.
you need to be transmitting so someone can hear.
Got to be there and ready to
Yeah.
break in. So you're going to be operating obviously on 6 metres.
Yes.
6 metres, 2 metres, 70 centimetres, 23.
23, absolutely.
3.4.
3.4, 2.4, and 10.
Love it.
The van is kitted. We don't have 5.8.
Working on that.
Yeah.
I understand that SG Labs is working on it as well.
Yeah. Well, they haven't replied to my last email about it, so
Right.
maybe it's further away than. Or they could just be busy.
What you could do is you're quite welcome to take one end of the AV transmitters up if you would like to. Up to you. And then you can get 5.7 to wherever I'm going, which I think is Eagle Hawk Neck again. So that's where I'm thinking.
Let's talk about that later. That might be a little bit ambitious. There is a lot of
the problem you've got
packed into the van.
And the problem you've got with that particular direction is you really need to be on the other side of the road. Because that was the problem we had with 10 gigs last time I was down there.
Sure. Are you taking 10 gigs this time?
No.
Fine. Are you taking 3.4?
Yes. Yes. I'm taking 6, 270, 23 and 3.4.
Right.
I've drawn the line at 10 because my 10 arrangement is somewhat
Too hard.
tenuous at the moment.
Right. Okay. No, that's fine.
Yeah.
And that means we can just set it up pointing north, and we don't have to reset that.
Correct. Correct. So yeah.
So yeah, look, hoping for some
This
for some openings, and for those of you who don't know anything about Moxons, which is probably me included, Justin just educated me on an interesting fact about Moxons.
Excellent front to back ratio. Excellent. Now, what I'm doing here, sorry, this is really slow. Which really should be. I'm getting there. I'm really getting there. Now, that's what I want to show. That's the critical bit.
That's the insulator in between.
So one side's the dipole, the other side is the reflector. So the driven element and the reflector, and you'll notice that particular gap in there is fairly critical, but also you'll notice that the driven side is actually, if you do the measurement, slightly less than the reflector side, which is quite obvious there. So yeah, and it's Les Moxon. We talk about the Portsdown project coming from the UK. Les Moxon was an Englishman, and produced lots and lots of books on Moxon antennas. So yeah, and make fantastic 20-meter, quite compact 20-meter 2-element beams.
Well, look, we picked it because it was compact. Because on the field day ban, any other 6-meter antenna you plan to put there is going to hang over. It's going to need assembly and disassembly once you get on site. And for those of you not familiar with Mount Wellington, it can be bitterly cold and windy, and sometimes the less time you can spend out at the van, the better. Now, with this particular one here, we should be able to erect this in probably under 3 minutes.
Fantastic. Okay.
And pull it down in under 5.
Okay.
And pack it away.
Is this staying on the mast like
this
the others?
This stays on the van like the others. Yep.
Yeah.
Yep.
Okay.
So you but unlike the others, to travel, this needs to spin at 90 degrees, just so that it doesn't overhang the side of the van.
Yeah. Okay.
So there's a little bit extra now. I've got to get up, turn it, put the bolt in to hold it, and then untangle the coaxes, and then hit the button, and up goes the compressor. So,
okay.
All right. Yeah, no, I'm looking forward to giving it a whirl. It tunes up nicely.
Love it. Love it.
Cool.
Thank you, Murray.
Pleasure.
Oh, hang on. There's another one here.
Yeah, yep. Take that one back.
One you preferred earlier.
And a big thank you for Ken KOJ who printed and designed these. This is his design.
And can I just say the everything's got, like, this little strain relief here has got cell foil actually printed into it. So for cell foil, and then there is RG58, which I think's on that one.
Yeah.
And there is VK7KRJ printed into it, which is fantastic. And all of the little strain reliefs and all of the little holders are all, they've taken the edge off it so that the hole is actually printed. Yep. So there's no strain on the coax. Well, there's no. I
learned something about the detail of 3D printing in this, because these are all threaded. You can see there's 3mm threads through here.
Yeah. Okay.
And I looked at them. I said, "Oh, you cut those pretty clean with the tap." And he goes, "Oh no, I printed those threads."
Flippin' heck!
So the 3mm print.
Is printed threads is a 3mm.
That's right. Because of.
Wow.
Yeah, I know, right?
I must admit the finish is really is quite fine compared to some of the stuff I've seen, which is pretty coarse.
Yeah, Ken's a bit of a perfectionist. He's printed a bit of stuff now. He's worked it out.
Fantastic. I love it.
Yep. All right.
Thank you, Murray. And good luck at the field day.
Oh, thank you. You likewise.
Yeah. This will be good. Now we'll just do a bit of a reset. We will actually do a bit of a reset on the the studio right at the moment because I need to set the next thing up. So so stand by. I'll just go to test pattern and we'll be right back with a reset studio. Okay, we're back in the studio, and we've got the next item set up. Now, one of the and I'll just turn that down. One of the things I've just got to remind people of. Hayden on the Ham Radio DX channel has been posting progressively the presentations from the Tas Ham Radio conference. So I think the first 3 are up there, and progressively the others will appear. They are available if you have a look at the playlist as unlisted videos, but they'll be progressively appear on the Ham Radio DX Tassie Ham Radio Conference playlist. So worth a look. Now, I have been banging on in previous sessions around the short 160 meter top-loaded antenna that I've been playing with, and I've been wanting to do some ground plane tests, very similar to what we did with Kim Briggs, who bought a field strength meter up, and we did field strength improvements by putting out ground plane wires using 936 ABC FM, ABC Hobart, the AM radio station. That gave me an idea about, I wanted to do some ground plane measurements on the 160 meter to work out what the minimum amount of ground plane wires would be to get the radiation angle down to a DX type level. And so I suddenly thought, okay, that's fantastic. I can use a very similar arrangement. I can transmit 160 meters from my home QTH and then come up here where I've got a wonderful ground plane already in the ground. And so I can do a A/B test with no ground plane and then the almost perfect ground plane up here. There's a whole lot of copper, for those who don't know, on top of this compound, which was used by OTC when it was a coast radio station. So, but then I thought, hang on, I have to be actually transmitting from South Hobart and up here, and can I do that remotely? Can I do that in some way, shape or form? Well, I thought, okay, I need a Morse code keyer that puts out a signal, so I'm putting out an ident at least every 10 minutes. I'm putting out a carrier signal for extended periods of time so that I can get average levels on a field strength meter. So I thought, how am I going to do this? I thought I need a Morse code keyer. And so onto Arduino, the Arduino library, and put in Morse code keyer. And there is a wonderful, wonderful Arduino Morse code keyer that's been made available by Nelson Farrier. And he talks about, he's obviously an amateur because he is using his Baofeng UV3R radio, and he's used some routines from Mike Myers as well from the Arduino library. And so what I actually did, an evening to Gary, VK7 Joe GD. So what I actually did was, I'll change to this camera so that I can just move this other camera down to another thing on the seat. This seat's very popular tonight. So what we've got is, and I'll whiz around the corner. I built up a little Arduino. This is a little Arduino Uno, fairly popular little board, available from JCAR and a variety of other outlets. I built up a little daughter board, and this is a little bit of matrix board. All it's got is on it is a here we go, is a relay which is switched by one of the I/O pins. There's an output pin which goes through a little audio filter with a bit of AC coupling, which gives you your tone out. There's an LED which gives you whether it's on or not, and then there is the output is one of the outputs is used to switch the relay, which is the push to talk output. So push to talk, it comes out currently set up for a ground push to talk, so it grounds that signal to push to talk. And then the tone is generated inside the Arduino through a little routine, and the tone comes out through this network and is AC coupled into your transceiver. Now, if I turn up the, I've got it connected to a little powered speaker, so you can hear. You can set the rate. You can set what it transmits, and I've got it. Transmitting my call sign and a little statement which is 160 meter ground plane experiment, and then in between those messages you can put a certain amount of carrier length of carrier that you want there, or a tone that you want there for and now I've got it just as a second, but I'll increase that up to probably at least 30 seconds or a couple of minutes each time, so that I can see the here we go. 7TW 160 meters ground plane experiment. So anyway, so this puts out and it's keying the push to talk as well. It puts the push to talk low and then transmits this and then brings it back up high again so that it stops the transmitter. So this is a little Morse code keyer Arduino project available on the Arduino in the Arduino library, and you can find it if you put in auto keyer for radio fox hunting. And it's all open source, so you can use the code. It's actually I remembered I had one of these little Arduino cases, very nice little cases, because they actually have the posts built into the case, which go through the holes in the Arduino, and mounts the Arduino in it quite nicely. You can put these little daughter boards on there. I put a hole in there for the LED, and then just brought the others out to the RCAs, which I can then make into whatever cable I need for the particular transceiver. So, and it's still merrily transmitting away there. So anyway, that's the Morse code, Arduino Morse code keyer that I will I'll be using I'll be using for the field strength. So what I'm intending to do is set that up at home. That'll be transmitting on 160 meters at a certain power. I'll use the field strength meter at home and actually measure in absolute terms what is being put out. Then I'll come up here and I can then do an absolute reading of what I'm measuring there from field strength point of view, what I'm measuring here from field strength point of view, and then go through and put 4, 8, 16, 32 ground planes on and see what that actually does and how it improves the field strength. And it's doing that through, as I add more and more of those ground plane wires on, it will be lowering the radiation angle. That's what the theory is telling me. Yeah, it's and I can document all of that, and I'll put that in the AR article that I'm actually writing right at the moment about. Let me just that's oh no, don't want to do that. Let me just make that focus a little bit better, or it's going to drive me absolutely crazy. That's a bit better. So that's the arrangement, and that's the Arduino Morse code keyer that's available on the Arduino library if you play with Arduinos. Absolutely wonderful little device, and I think I'm right. That's the project that Hayden used for his Fox. Little keyer that he keys a Baofeng radio, and you can get it to say anything you want, a certain amount of carrier, no carrier, etc., etc. So very impressive little project. So I'll report back once we've done those tests. It'll be in a couple of weeks' time. Now, just to finish off, next week we'll actually have special guest in the studio, Bob Stevenson, who is VK7BS, who is doing lots of work right at the moment at the Margate Men's Shed, setting up an amateur radio station at the Margate Men's Shed with help from Brian, VK7BW, and Gary, VK7JGD, who's on tonight. So evening, Gary. So they'll be coming along. Bob will be telling us all about what they're doing down at the Margate Men's Shed. So fantastic. And also we hopefully will have a little bit more around the Portsdown 4 project and be able to demonstrate the transmission of some DTV signals. So that's what we'll get up to for a little bit of next week. So now, final reminder, our next event, 7th of December, up here from 5 p.m. There is a free barbecue for members up here. Please come along. Snags, hamburgers, veggie burgers, blah, 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 from 5 p.m. Bring along your favourite beverage or whatever, and just enjoy the end of year, and also the successful year that Reast has had. So 7th of December, it's a Wednesday night, end of year barbecue. So yeah, we've got a whole bucket load of videos for our RF viewers, so we'll go head into those in a short while. So this has been VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And yeah, we'll see you, bid you 73, and see you next week. Cheers.